Hi, here's the assignment, and I'm calling this 4.1 part 1 because we will have a section with a few more problems in 4.1. Okay, so I'm going to go over question number 22, and this should help you kind of gain some connections between these the lesson and the problems I assigned. So question number 22 states, Go Blue. Michigan Stadium is also known as the Big Blue House. Seats over 100,000 fans for a football game. The University of Michigan Athletic Department wants to survey fans about concessions that are sold during games. Tickets are most expensive for seats on the sidelines. Okay. So I'm going to need a section to write. So I kind of added a page there. So the sidelines, so that's this. These are the most expensive. So I'll put $3 there. The cheapest seats are the ones in the end zones, where one of the authors sat as a student. A map of the stadium is shown. Okay, so this would be like medium expensive. So this reminds us of, my daughter changed this pen and it's going to drive me crazy. This reminds us of our Justin example, right? So if we look at the seats, we notice that the happiness was higher here. And again, front row seats are more expensive and probably the cheapest seats are in the back. So happiness rating may differ based on the price of the seat, or your how big of a fan you are might change how much money you're willing to spend on a ticket, right? So if we are interested in surveying, we might want to separate in these strata. So let's look at the question now. The question states, describe how to obtain a sample using a stratified random sampling. So this is like our Justin Timberlake example. Explain your choice of stratus, we kind of did, and explain why this method would be preferred. Okay, over a simple random sample. So if I go to a place to write, so 22A, we see that we want to be able to use the 3 types of seats: sideline, corner, and end zone as our strata. And the reason why is because the ticket price differs between the 3. Types of seats. We also see that they're the same within, the price is the same within the group. So there's no reason to separate further because within that group they're the same. So, and the reason why, so we're thinking, well, what was the reason why? Well, we kind of said we think that people who can afford, or if they're just extra enthusiastic, more expensive seats probably have different opinions about, I guess we're asking these people about, the question we're asking them is we're interested in finding out how they feel about concessions. And this could differ than people who can only afford cheaper seats. All right, so if they're asking us, explain your choice of a strata, I did. I decided to do the 3 types of seats. And then tell me why. And then because of the whole Justin thing, right? Because of the Justin thing, we noticed that if we combine these into one sample, it would be less precise in approximating opinions, right, than it would be if we stratified. By seat type. So we're doing this so we'll have a more precise estimate. And again, that means if we kept the size the same. So in just an example, we kept the sample size the same each time, 10, 10, 10. Yet the one that was the most precise was, even though the same size. So if we combine these in one sample, it would be less precise in approximating than if we stratified by seat type using the same sample size. Okay. Now, 22B. They also ask us, describe how to obtain a sample using a cluster. So if you were thinking about this in your wording, and then I think I also talked about cluster sampling, kind of a convenience sampling, but it's different. Explain your choice of cluster and why this method might be preferred to simple random sample. So if instead of doing a stratified sample, which is what we explained here, what if we did a cluster sample? Okay, so first we got to make sure we know what a cluster sample is. So if each numbered section could be used as a cluster because it's easier to hand out surveys to everyone in a numbered section, then we could randomly select several numbered sections and survey all the fans in that section. So clustering sampling would be more efficient than finding an SRS of fans scattered throughout the stadium. Okay, so cluster sampling is more efficient, easier to administer, so that would be the benefit. So it said, describe how you would attain the sample and explain the choice and why this method would be preferred. Would be preferred because it's more efficient. It'd be easier to take the sample and to hand out the surveys to the people in the numbered sections. And we could randomly select a sample. So what do I mean by this is if you see all these orange ones, right? You see all these orange ones? If instead of randomly selecting, giving everybody in the orange section an equal chance of being chosen, what if I put these numbers in and gave each section an equal chance of being chosen, and then let's say at random, this section got chosen, and I hand out the survey to everyone in this section. Instead of randomly talking to that same amount of people randomly dribbled throughout the whole orange section. That's what a cluster sample would be. So let me explain that. I did visually, but I'll explain it in words again. To do this, I would I could use each section number as a grouping and randomly select whole sections. Now, as I was talking there, I realized I blended the two because you know what? That's probably what they would do in real life. But I want to be careful here. The question doesn't say to blend the two. So let me actually go back. If I do this truly as a cluster sample, then what I would be doing is I would give each of these outside section numbers an equal chance of being chosen. So maybe this one would be selected and that one, and maybe this one and that one and this one and that one. And then that's it. So I'm going to choose these 42, 39, 34, 23, 20, and 8. Notice just by checking sections, I might get hardly any yellow, right? Maybe more of one color. So there would be pluses and minuses, but this cluster sample would be much more efficient and easier to administer than a pure simple random sample. And I could use each section's number as a grouping and randomly select the whole section or sections. All right, that's it, guys. Thanks for joining me. See you next time.